Hi, I'm Sam Jabley, and you're watching the video for my Lab 1 charged tape for Physics 2212. A quick introduction before we get started. In this lab, pieces of tape will be charged by laying one piece on top of another and then ripping off the top piece. The purpose of this lab is to observe the interactions between the two charged pieces of clear tape and then to determine the amount of excess charge on each piece. And the hope of this lab is to showcase the principles of Newton's second law, Coulomb's law, the law of gravitational force, and how they are related to each other. So, some details and results preview before we get into it. The system of the experiment is the tape that its two ends are resting on the two objects a distance apart, which is also known as tape B. The surroundings of the experiment is basically everything else, including the tape below that's going to make tape B float. The experimental model is the physical experiment, and the computational model is created using GlowScript. And a quick results preview. Each tape's charge is calculated as 2.33 times 10 to the negative 9th power coulombs, and the number of electrons lost was calculated as 1.46 times 10 to the 10th power. So, some fundamental principles. Newton's second law, a system's change in momentum divided by change in time is equal to its net force. Basically, F net equals mass times acceleration. And now we have Coulomb's law, which describes the calculated electrostatic force between two charged particles at rest. And here's the equation for Coulomb's law with K as a constant. And the gravitational force describes the force of mutual attraction between two objects with mass, with big G being the gravitational constant. So, for the experiment, the base tape was put onto the table, and then the U-tape was placed on top of the base tape. And here's a picture of my actual experiment here. The U-tape was pulled off fast, creating a charged piece of tape. And it was determined that the U-tape is positively charged as it attracts to a pin that is negatively charged via rubbing with a wool shirt. And down here you see some numbers that are initial values from this experiment. So next, I took the original piece of U-tape and placed it on two red cups here. And another positively charged piece was then created using the same method and held under the original piece to see how far the top piece would float since like charges repel. And it was determined that the top piece floated this distance, 0.05 meters. So some calculations from this. I calculated the gravitational force by doing mg, and I drew the free body diagram. And since tape B is at rest, the gravitational force is equal to the electric force. And to find the electric charge, I just plugged values into this equation and found the electric charge. And then to find electrons lost, I did Q-tape over the magnitude of the charge of an electron, and I found the number of electrons lost. And then I found this ratio of number of atoms to number of electrons. And so now you have the computational model, and I just put in a bunch of constants here and variables here like tape mass, tape length, width, and distance that I found earlier. And here I inputted all the important formulas that I just did in the calculations previously and basically printed the results. And here's the results of the computational model, which the results of the computational model were actually pretty close to my experiment results. So some assumptions and errors. You assume that air resistance and friction are negligible and that the long tape is a point charge. Each piece of tape does have an equal amount of evenly distributed charge in this experiment as an assumption. And some errors as a result of this is that an unequal distribution of charges in reality means different answers from the computational method. There's also a loss of charge to the surroundings, mainly touching the tape. And there's a measurement of values such as distance and length being off by slight amounts. So, a quick discussion. What if electrons and protons had inverse charges? Well, the results would remain the exact same, as both pieces of tape would be negatively charged and would repel since like charges repel. They would still be attracted to positively charged items like the pen, which is now positive since charges are inverse. And why is it important to handle the tape as little as possible? It is important because initiating contact with charged objects neutralizes those objects as they try to gain back the electrons they have lost. Thank you so much for watching. I hope you learned something in this lab, and I'll see you next time.